Okay, this is a flowchart for executing the stepper motor control. Okay, start. First initially start the process. First initialize 8255 the port A as output port. Then store the switching sequence in the memory location. Then set the counter. Then out the data from the memory locations to stepper motor coil. Then call for delay. Then decrement the counter. Then increment the memory location. Then so this value is 0. 0 means if 0 is okay, if 0 means it will goes to the initialized position, then start switching sequence. If no means it will go to the set count. So this is the concept. Once we are executing this program means the stepper motor will continuously rotate. Okay, if you are exiting in the reverse directions means it will be used as a reverse anti-clockwise stepper motor rotations. So step 3, here step 4, step 5, step 6 and step 7 having the same concept, that flow chart converted into the steps like this. So this is a servo motor concept. So the servo motor also based on the base of the stepper motor. Okay, this is the concept of stepper motor. So this is used in the most digital motor used in the robots, Xerox machines like conveyor belts like that. They are using the stepper motor with the different conditions for different requirements. Okay. So next one is temporary traffic light controller using 8085 microprocessor. That means we are going to control the traffic light with the 8085 processor. Okay. So in this condition, the main problem is how the 230-volt bulb will connected with the processor. Okay. First, this is the main uh, criteria we need to discuss, because my bulb is working the 230 volt but microprocessor work in the 5 volt conditions. Okay, when interface these two means, so definitely the 230 will be affected on the processor. Okay, let's see the solution for this process in next chapter. Okay, so let's see the traffic light controller. So the 8085 microprocessor is a popular microprocessor used in the industries for various applications such as traffic light controller. Okay, the traffic lights can be automatically switched on or off in the desired sequence. The interface board has been designed to work with the parallel port of microprocessor system. Okay, generally we have four types of traffic light controls. So that is, one is normal time. Okay, normal time means the time will be less. So like that. So in peak time, the time will be high. The time duration between the green and yellow changing will be high. That is a condition of peak time. So in night time, there is no need of green and red. So we are using the yellow signal with the continuously. So that is blink of yellow signals like that we are using the midnight of areas. Okay, so you need to consider these kind of operations with the ports. Okay, so let's consider the this traffic light road with the conditions. Here we are using R1, Y1, G1, R2, Y2, G2 like that. We have four set of RYG, that is red, yellow, green. Okay, if we want to, so each bulb is connected with the particular port. If I give one to the particular port means the particular light will be enabled. If I give 0 means the light will not be glow. Okay, for example, if we want movement of vehicles between east and west means you need to glow the green signal G3 and G4 and enable the R1 and R2. Okay, first you have to produce R1 and R2 as a glow, same as east and west will be green, G3 and G3, G4. Okay, next for particular time period, after time period, we need to enable the glow the yellow, that is Y1, Y2, Y3 and Y4. Then after 3 seconds, we will go to the reverse process, that is N to S communication. So here we are using G1 and G2 as a glow, as well as here R3 and R4 will be glow. This is the concept. A simple concept. We are representing the each light with the particular port. That's all. So this is the interfacing diagram. So already we discussed. Already we know that a particular point. That is how we are connecting that to the world with the processor. So this is a small solution for this. Here we are using the electrical mount. So my electrical mount or metal mount of like that we are called. So when we are giving the one was 5 volt to the this pin means it will produce some flux in the metals. So when flux produce means the two mount are connected. So this loop will be closed. So this light will be blue. So this 230 volt not connected with the microprocessor because there it is a wireless communication here they are using. That is not wireless communication. It is a short-term communication of with the flux. Okay, if flux produced means the mount will be connected, the light will be glowed. If not flux produced means the mount will be open, so there is no glow in the uh, bulb. Okay, this is the concept. Okay, here using 8255. So these signals from the 8085 controller. Okay, this is the program for traffic light controller. So for each program, they are setting the different time period for the process. So there is a time for one T state is equal to 1 divided by 2 megahertz is equal to 0.5 microsecond. So this is the equation for count, required delay divided by time required for one loop. Then answer is A2C2H. Okay, this is the concept of traffic light controller. So today we discussed about two concepts. One is stepper motor, another one is traffic light controller. So stepper motor controlling through the 8085, then traffic light controlled by the 8085. Okay. Okay, thank you. We will see in the next class.